30 seconds. Oh gosh, I gotta deal with you. There we go. Oh, great. Make faces at him. All right, apparently we're live now. Hello, everyone. I'm Brian Reed from Team 973. I'm a mentor on that team. I've been on 973 since 2007, so this is coming on my 13th, 14th season with them. Yeah, I mentor the electrical department and fabrication and assembly teams there. So yeah, how many of you guys are new to the FRC season here? Raise a hand. So quite a bit, yeah. So some of the tricks and trades that we have learned over the years to come up with world champion robots. Yeah, so just some basic electrical basics: volts, amps, ohms. Volts is the volts. It's been a while since I've done a presentation in front of you guys. So volts, amps, and ohms and watts is what you're going to use to do most of your measurements on the robot. Ohm's law is a good thing to know when using a robot. You're not going to really need to know most of this, but volts for your battery voltage, amps for how much amps is going to go through all your wire, and ohms for resistance to wire. So wire comparison. This is one of my, yeah. So 12 gauge wire, use quite a bit of a wire. I should have prayed. I've been working all week, so I should have prepared a little more than this. But yeah, 12 gauge wire. I'm in here. Okay, 12 gauge wire. Yeah, so on the larger wire, less resistance for when we're running a lot of current through it. So on our drivetrain, we run 10 gauge wire to our main sims on there because our main sims are going to be drawing a lot of current compared to our 12 gauge wire. We're running 4 gauge wire from our battery to our PDP for our main breaker and main wiring, just to get all we possibly can out of it. The 6 gauge wire, since that is the minimum required for FRC robots, you can get by with it, but it tends to heat up and melt sometimes. I've seen them melt. I've been a robot inspector for 10 years, so I've seen a lot. So I tend to push everybody towards the 4 gauge wire for all the main power distribution on that from your battery connection to your main breaker and from your main breaker to the PDP. Go over some of the basic components here. Oh man. So flow of electricity through an FRC robot starts from the battery and then goes into PDP and through the main breaker. And then from the main breaker, it goes off to all of our devices. So we have our Robo-Rio, our pneumatics module, our voltage regulator, air compressors, our talons and speed controllers. Everybody know what Robo-Rio is? Robo-Rio is the main brain of our robot. That's going to be controlling all of our talons, reading all of our sensor data, and basically doing everything. Your programmer will program that. Yeah. And then we got our talon speed controllers. That's what control all of our motors. We got to be able to turn the motors on and off, so it's got to go through talon, or there's some other controllers that are named on here, Sparks, and some Victors that are not listed on here. 973 likes to use the Talon SRXs with the CAN bus. We are really over PWM wires. We've done years and years and years of PWM wires, and it's so happy not to be doing PWMs anymore. And then plus all the power now that the Talon SRXs have with all the control loops that can be just done on the Talon SRXs, and how we can just wire sensors straight into that and have limits and all that built in, this reduces a lot of unnecessary wiring now that we have to do. We really, really like the Talon SRXs. Another couple tricks that we do is on our pneumatics control module, the air compressor is powered from the pneumatics control module. It's great because you don't have to do any code for your air compressor. But the one thing that first did for us is put it on a fuse. But you don't have to do that anymore per last year's rules, is you can put it on a resettable breaker. But we still don't like running it through the pneumatics control module. So we'll run it the old way through a spike, controlled with a 20 amp resettable breaker and a spike, and run the compressor straight from the Robo-Rio and pressure switch off of that. We're just really, really worried about having the pneumatics control module break. Yes? Yeah, no problem. Yeah. Yeah, so our pneumatics control module runs all of our solenoids, air compressor, and reads our pressure switch. It talks CAN bus to the rest of the robot. The main loop of the robot is CAN bus. So it'll talk to our PDP, our power distribution panel, which distributes all of our power to all of our devices. So we'll have breakers, fuses in there. They'll run off to our Talon SRXs and to our motor and off to the Robo-Rio. Yeah, so we also got the VRM, our voltage regulator module, VCM. I don't know why they call it VCM, but it's VRM. Our VRM is our regulated power for all of our sensitive equipment. So we'll have, like, if we need a consistent 5 volts for a device, that's got a buck boost converter in it that'll raise and lower the voltage as we draw power from the battery. So when we're drawing power from the battery with all of our sims and stuff, it lowers our voltage a lot because we're drawing a lot of current. Yeah. So where was I? Pneumatics control module. So we back to, we run everything off the air compressor, spike. VRM runs, we have a dedicated line that we got to come off of our PDP to run our VRM. There's specific spots labeled on there that we have to do per the rules. And that also powers our radio, which is a Wi-Fi router from First that we're required to have. So we'll run, that runs off of that as well. We'll also run some of our custom circuits that we'll have sometimes for, what did we have last year? We had what did we have last year that was custom? I don't think we had too much custom. But we'll run like if we do a custom circuit for some sensor of some sort that needs a very controlled power voltage, we'll run it off the VRM. So we'll come back to Robo-Rio and that. So the Robo-Rio connects to the access point through an Ethernet cable, standard Ethernet cable. Most of the time, we don't have any other Ethernet devices on our robot. We'll just run the one Ethernet cable to the radio, and that's all we need. And then we'll allow the other port for our tethering. We'll run a breakout connector on our robot, like just a RJ45 jack that you can purchase at Home Depot or something, and we put it on our robot. We don't, once we set our radio in our robot and we attach it to the robot, we never take it off the robot, and we hot glue and pot all the connections into our radio so that we are never disconnecting it. The
So when you go to an event and you reprogram it, you take the whole robot to the
yeah, we take the whole robot to the table. We'll also take a second radio that's on the same board with the Ethernet cables already hot glued and connected, and reprogram that as well. So we'll just hot swap if we have a problem with it. We never really had too many radio with this radio. We run the older generation radio. There's the 2 generations of radios right now, and we run the older generation because some of the software, we just like that older one. So we hot glue, pot everything in there. We use it PoE. We use power over Ethernet to power the radio. We don't like using the barrel connector on there. The barrel connector we've had other teams break the barrel connector internal to the radio. We've seen failures of the solder joints inside there. So we use the power over Ethernet, and then we'll hot glue and pot the Ethernet cable in. Yeah.
I'm just curious, why do you hot glue it?
The Ethernet jack is the world's worst connector. It is like the most terrible connector known to mankind. It's meant to be plugged in once or twice, and it doesn't like the way the pins and everything in there, and the way it connects to the Ethernet cable. It's spring tensioned in there, and over time, that spring tension of the connection points gets old, and so if it rattles around and moves around inside that jack, we've had it loosen up and lose connection over time. Yes.
So are you using the cable or just one of the older versions?
The older open mesh ones. We have to use the open mesh. So the older of the open mesh ones. Yeah, so we power over Ethernet for that. And then it's really important, it's that connection for the tether, we really like to break it off. Teams like to plug in and out of that radio, and the radio is your most important piece of the robot next to your Robo-Rio. It can't talk to the field without the radio. So we treat that very, very well. Sometimes we'll even shock mount it, depending on where it is in our robot. We'll shock mount it on some foam to keep it from breaking and having solder components. The D-Link ones were terrible, having things break internal to them. There was a switch on the D-Link ones that we had so many problems with those switches. So we'll even pad mount that radio and break off for the tether port, and have a sacrificial port. So if that breaks, we'll just redo that one and do that. Any questions on this slide so far? We're probably going a little quick. Great. So in FRC, they release new rules every year. They haven't changed too much over the years on most of the wiring stuff. They changed some of the motor rules every year to year. So last year was pretty lenient. Go through the rule book every year, read the whole robot wiring section and the pneumatic section. The pneumatic section last year was opened up quite a bit compared to years before. And yeah, so they might change the CV rating of some of the solenoids some year to years. It's really important to read through the rules, even though it seems like they haven't changed much. There might be a few details that could get you some years. So yeah, for a while there was I'll come up in the next couple slides. For a while there in the pneumatic section, there was a required blow-off valve that we were supposed to use, and they finally opened up that to where we can use the McMaster-Carr one instead of the one that comes in a kit of parts. So over the years, I've inspected robots. There's a lot of rules that I've seen broken that come up a lot in when we're inspecting robots. A lot of them is the wire gauge rules, depending on so for each circuit breaker off of our PDB, we are required to have a certain gauge wire off of that. So from 31 to 40 amps, we have to have at least 12 gauge wire for that circuit. For 21 to 30 amps, it's 14 gauge. And then between the PDB and the VRM and PCM, it's 18 gauge minimum. And then between the PDB, Robo-Rio, 22 gauge. I see that rule violated a lot, for all sections of that. So very important to pay attention to your wire gauges. The inspectors, some inspectors in some areas make you even have the wire label show it. The wire have the label on it. But most inspectors can tell the size of the wire using their eyesight. But just really important to get the wire gauges right.
So, to your point, it's okay to oversize.
Oh yeah, so oversize sometimes. Yeah, so for the 40 amp circuits, we'll run 10 gauge to most high current drawing items. We'll run 10 gauge to our drive train to get as much possible out of that, so we're not heating up that wire, getting more resistance, causing issues. Yeah, oversize. Well, not oversize. So sometimes we'll go so crazy, as we're so close to weight, we'll go back sometimes and change some of the gauges of wire so we can make weight. The oversizing does not violate the rules. Yeah. Is yes. Yes. Yeah, sometimes, depending if you got new breakers or not. Yeah. It will find your weakest link. It'll find, most of the times, I've seen it find just the crimp, loosest crimp, and melt there. So some other common violated rules that I've seen over time is the circuit breaker placement on the robot. I've seen them very buried inside of spring-wound mouse traps. So the placement of the circuit breakers, safety for everyone. It's got to be accessible in a quick emergency situation. So that one's pretty violated a lot over years. So place it in an area that's not going to be next to a chain sprocket on your robot or a big sprung held item in your robot or underneath your elevator or arm or something that can fall on you when you turn her off. Like last year we hung, and the first thing you got to do when you get on the field is turn off your robot. So you don't want to put your main breaker underneath your elevator that you hung off of for it to then fall on your hand. I've watched teams do that before. So placement of the breaker. And then one or more connections to the Wago connector on the PDB. For some reason, people like to violate that one, which is bad in multiple ways. They'll put two 12-gauge wires underneath the 40 amp and run it to their drive. So it'll heat up that connection, and plus you're drawing more current off that circuit than what you should be for a drive train or a motor system or something like that. So one wire underneath each Wago connection and on your PDB. Questions so far on commonly violated rules? Every year we'll work together with our programmers and our electrical sub team and make a Google spreadsheet of where all of our I/O will be on a robot. So CAN addresses, what sensors are hooked up to each Talon or each RoboRio port, and it makes it just really simple to communicate to the programmer. And when we're troubleshooting at the competition of what sensor is supposed to be plugged in where or how or why this isn't working, we'll commonly print this out and laminate it and keep it in our pit. Pretty much every year we keep it laminated in our pit and have a very well documented electrical system of where all of our sensors go. Going with this labeling, our stuff when we're running our wires, we'll commonly label all of our sensor places. Wherever we plug in our sensors, we'll label all the connections for that. We don't really do the power distribution side of labeling that. We don't find that we really need to do that. We don't really have troubles in that issue area when we're at a competition. Our main power distribution to all of our motors and things like that, we'll have that fine. The area that we have the most problems is with sensors and our limit switches and things like that. That's where we'll have problems at. Yes.
As far as the wiring goes, how did you guys actually manage how that's going to work? From like an outside perspective, just like
I'm getting to that. Yeah, I'll answer that here in a second. But yeah, so the first thing we'll do is come up with this spreadsheet, figure out what systems are going where and what amperages we want to allow for each system. So if we're doing an elevator that we're going to be hanging off of, and we want to have a 40 amp circuit available for that, but then we also have some claws that intake to cube like last year, that we want to have a lot of power to that too. So it's a big fine budgeting act of where we want to allocate the 40 amp circuits compared to the 30 amp and 20 amp circuits on a robot. So we'll go through that and spend a lot of time figuring out where we want to put the most power to. So I work actually as an industrial electrician in the automation and control industry. So we do really large robots, breweries, factories, and things like that. And I run into a lot of things like this that just take forever to troubleshoot issues with. And so cleanliness is your friend when running electrical items. Spending time to figure out where things need to go, lay it out. We'll spend a lot of time. We'll get from the design team a layout of what our drive frame will be, and we'll commonly print that out on a plotter and spend a lot of time laying it out by hand. A lot of people like to CAD it up. I don't like doing that, and a lot of the kids I work with don't like doing that. We just like to lay it out by hand. We can see how the wires go and see the flow of all the wires and see how we can move things in certain locations. We'll spend a lot of time placing components, attaching it to the table, look at it for a day, come back, look at it again, make sure something's not hitting a component or item on the robot down in the future. So we'll spend most of our time laying it out. And then from there, once we got all of our components placed and set, then we'll start wiring each component. Last year was the first year we had a restraint that we hooked our Talon SRSs up straight to the PDB this year just to keep less connectors and resistance in the path to our drive. So we hooked our Talon SRXs straight to the PDB, so we kept them as close as possible. We didn't trim the length on the Talon SRS wires that come with it. You guys know that they all come with a fixed length of wire on them. Most of the time we'll put an Anderson connector on them, but this year we did not want to do that just to keep the most resistance out of the drive as possible. We ran a 3 mini sim drivetrain on either side of our robot this year. So from there, it's kind of an art form now of laying out each wire. We'll spend a lot of time individually running wires in right angles and zip tie paths that we've developed after placing all our components. We'll go through and put zip tie pathways down with zip tie holders where all of our wires are going to go and make sure everything's going to dodge everything inside of the robot. If you look in this picture to right here, it's a little bit more messy because this is the year that we did not do the straight connecting the Talon SRXs to the PDB. We had pigtails in between the Talon SRXs and the PDB. This is a little short Anderson pigtail. We use a lot of Anderson connectors on our robot. I know they're expensive. There is spade forks and connector packages that you can get that are way cheaper. I like to have the ability to remove a component at any point in time without having to cut the wire. And when you're at your competition and you have something fail, time is of the essence. So the last thing of doing is cutting and stripping a wire and crimping it when you're out of limbs. You just don't have the time for that. So we'll connectorize everything. So we're just plug and playing when we have something fail. Last year we didn't have a single electrical component fail on us. In years past, we had a PDP, the version older than what you're currently on right now. We had the voltage regulator inside there started giving us a weird frequency off the voltage regulator. It failed in some manner that it would not power the C-Rio at all and was interfering with it. So we had to replace that main PDP in a competition. And that was, since we had everything connectorized, it didn't go that bad, but that was a pretty bad one to replace. So yeah, a lot of connectors. We'll spend a lot of time laying out the wire. We'll spend a lot of time laying out the wire. We'll spend probably a good week laying out the wire on that. Our practice spots are terrible. I can tell you that right now. We'll do at least 2 practice spots. So our first practice spot will be a big spider mess after our first pass of laying out the components. And then we'll do our second practice robot. It'll be a little bit better, but by the time we're at comp, we've got it nailed down, and it's pretty cherry at that point. Yeah, some more component time that we spent laying out components. Yeah, just we in past years we used a zip cord from McMaster-Carr a lot. I've gone away from the zip cord just to running machine tool wire in situations from our power distribution from the PDB to our talons and speed controllers and spikes and things like that. It just makes it a little bit easier for us to get that even more laid out. So on zip cord, you can't, if you turn a corner or something like that, the one length will be longer than the other, and we were wasting a lot of zip cord. So we've gone back to just stranded single conductor wire and running each conductors to each device, and so we can even get it more compact. We can compact our wiring looms and stuff a lot more tighter and in more spaces through the robot with the single conductor wires through it. Yeah, we'll spend a lot of time on that. Yeah.
Are you taking questions?
Yeah.
So last year on mechanics, we gave the robot to the electronics team at about 6 p.m. on build day, on bag day.
Yeah, that's common.
When we talk about having a lot of time,
Well, hopefully at that point in time, you've gotten, you know what your drive base is going to look like. So we do a lot of pre-wiring, pre-wire looming before we even get the robot. We'll lay it out on a table and have a plotted base. You can even draw on a table what the areas you're going to have to place electrical components. So a little bit of foresight. You've been building a robot for a couple weeks. You kind of know what areas you're going to be able to place components, right? Yeah. So you can take that and start running wires. We'll leave things long. We'll commonly leave things long and trim it when we're there, but we'll have a lot of it
lay it out on a board, and then as soon as they give you the robot, you
we'll
can off the board and check it.
place it on there. Yeah. Yes. Give them room. On our side, they'll never leave a space. So we'll never get a space to do it. So last year we had a big in the front of our robot. The cube came into the robot, our first revision. So we had about a foot by 10-inch space to put the PDB, RoboRio, 12 talons, all of that. Give them some space. Remember that you need a battery and you need those components in places. A lot of people forget that they need those things to make the robot function. So when you're doing that, that's my suggestion. Is just don't forget about them. Make sure you leave them a little bit of space. Tell them that, hey, we're going to be taking a lot of your floor space. We have a belly pan most of the time, but in years past, I've had to put all of our speed controllers in a 2x1 space on the side of our robot. So in a 1-inch square by like 8-inch tall section, I had to place 6 Talon SRXs on either side of our robot down the frame rails of it. So, and that was because they forgot that we needed 12 speed controllers. So just don't forget about them and leave them a little bit of time to get it done. Yes. In a season, we'll build 3. Yeah. Our first pass is a lot of 2x4s screwed together. In weeks, it'll develop more to metal, but our first robot's going to be 2x4s and wood and routed wood pieces. So by the time halfway through, we'll convert that over to metal and we're building our second practice spot at that point in time when we're doing that. So we build 3 robots, so we'll get the first pass of electrical on our robot, and then we'll get our second pass and third pass by the time on our comp bot. The first 2 robots are not the world's greatest electrical item. And actually, if you do a practice bot, it behooves you to spend time on your electrical in that area, because that's the robot you're going to be driving the most. In years past, we've just thrown it together because we haven't had time to, and it's really hurt us when we're traveled far to go practice and we're trying to troubleshoot an electrical issue. So spend the time on your practice bots if you're doing a practice bot. Treat it as the comp bot, because that's going to have your most time on your robot compared to what the robot is that's in the bag. Yeah. Questions? So sensors, we like to use we're really into the across-the-road electronic sensors now. We like their whole product line, their mag-based encoders. We use a lot of banner products. Banner Engineering makes a lot of unique sensors for detecting objects. So last year we used a banner sensor detected cube. It had a retroreflective tape on the other side of a claw, and it just crossed the beam. It's a through beam sensor. So we like the cross-load electronics encoders, they're mag-based encoders, and the Banner Engineering products as well. They have a vast variety of products. Yes.
Do you guys use IR sensors?
IR? Yeah, so that Banner Engineering one is infrared laser. It's infrared laser light. It meets the laser rules of FRC. So yeah, we use them a lot. Some of them don't require, there's diffuse and through beam ones. We've had issues in past with the diffuse items that don't need to have that retroreflective tape to bounce the light back to it. We've used them, but we've never been that happy with them. They'll still, even if it's the most expensive sensor you can buy, still the $20 one with the retroreflective tape works way better. And sometimes it is a little hard to get that through beam placed on your robot sometimes, depending on what your item is. But we always try to do at least the through beam on something if we're detecting like a cube or something like that. We'll use a lot of current measurement too. We'll implement current on our, through the Talent SRSs, we can implement a current limit on it. And we'll have different modes and stages called for different points in there. So we'll use the current a lot. We'll use current to zero our robot. So we're not even really using a sensor per se to zero our elevator or zero something. We're using the current to trigger, okay, I'm zeroed now. I'm backed all the way down to the bottom of our thing. So kind of a free sensor you get. Detecting a cube too. We'll had that banner sensor, but we also had a current measurement on our intake rollers last year to see, okay, yes, I really am drawing a lot of current. So yes, I have a cube. So that was a third check on there. We actually put 2 banner sensors and the current measurement to vote on if we had a cube or not, implemented it into that. And then a few years ago, we used a flashlight too to aim for shooting the balls in the goal the year past. Kind of a cheap little free thing that we found that worked out really well. So we used a flashlight. That was the one that we used a custom circuit to power it from the VRM through a diode bridge to get that powered. So, I know there's a lot of sensors out there that are expensive and items like that. Automation Direct has a good line of sensors that we liked. We use the IFM branded sensors, banners, Automation Directs. We use quite a bit of those, but we're really, really liking the cross-load electronics stuff now. The ribbon cable that you have to run in between the Talent SRX and the mag encoder, we've found all the connectors and everything. We make our own ribbon cables now for that, so we can run them way all around. And then that ribbon cable is really sensitive, so we'll get some wire wrap on that. Some you guys have seen the Chinese finger trap stuff. We'll run that on there and make that cable really ruggedized, because it's a ribbon cable with I'm thinking it's tiny wire. I'm not even trying to remember what size it is. It's 22, even smaller than that, I think. Yeah, it will protect that, because if we lose a sensor, it's not degrading. It's bad, but we'll have other things to catch that we lost a sensor and still be able to go. But we really want to protect those sensor paths. We'll commonly double stick tape that two items. You guys get that free VHB in the kit of parts every year, and that stuff's great. we'll VHB all those lines down, make sure they're attached and hidden underneath all the robots. Yeah. So we crimp a lot of Anderson connectors and crimp a lot of terminals. I know there's a lot of cheap crimpers you can buy on the internet from Amazon and Alibaba. We buy the good American ones. Your crimp on your Andersons or on your battery connectors or on all of that is that you don't want to have that fail. You don't want to have that crimp come undone or be not crimped appropriately to the correct crimped pressure. So we'll purchase the name brand crimpers. We'll purchase the name brand dies. Dies is the biggest thing, is the dies on the crimpers being correct to the crimper. So we'll buy the purpose-built crimper for that crimp. And we'll buy good wire strippers. We'll buy, actually, what ones are we running right now? We're actually running ones from Fry's Electronics that are the Greenlee branded ones. They're really sharp wire stripper. We don't use the mechanical strippers at all. They tend to break the strands of wire if you're doing it inappropriate, not right. It's really easy to goof up the wire insulation, not cut it clean enough for the crimp. So we'll buy all the name brand items for when we're doing our electrical tools. But you're going to need, wiring a robot, you're going to need crimpers and screwdrivers and all of that, razor cutters. We're a real fan of these Craftsman razor cutters, even though Sears isn't around no more. I still find them on eBay. They cut the wire real clean, sharp end on them compared to like your wire cutters or things like that. We'll get a nice square cut on it and get it into a crimp. It helps a lot when you're doing with the smaller gauge wire. These will cut them very, very straight up and down. There's not with a pair of like regular wire cutters, will smash into the wire. These will cut them nice and straight and crisp edge when you're crimping like a PWM housing or pushing down the IDC connector on the Crossroad Electronics connectors. Some more tricks of the trade. Hot glue. It's a great thing. We love hot glue. We'll have like 5 or 6 hot glue guns out at a time during the season, just to hot glue little things from coming undone. And if we need to take it apart, we'll just break off that hot glue and re-glue it again. So we'll always in our pit have a hot glue gun going at that. Lots and lots of zip ties. Lots of zip ties. If your wire's moving around and it's moving with the robot, moving around in your drivetrain, it's gonna loosen up a connector. It's gonna loosen up something. It's gonna get in your chain. It's gonna get somewhere. So we'll make sure that the wire's attached and not moving around, fixed to the base of the robot, fixed to a tube on the robot, fixed. We don't want that wire moving around. And if we have a joint or something that is going to be moving around a lot. So last year we had a wrist on our robot. There was aluminum wire that came around there. We'll actually connectorize both ends of that loom at some point in time on it. So if that has a problem, we'll take that chunk of wire out and put a new chunk in. Also, even to remove that component quickly. We'll spend a lot of time actuating that joint and watching what the wire is going to do, where it's going to fall. We'll spend a lot of time on joints just to make sure that wire is not going to ever get caught in itself, or if we need to like put a piece of surgical tubing to hold it in a spot while it's moving around and restrain it if we need to move that joint. Another thing we do is strain leave the battery cables. That your battery connection path, your main power path, that's your main vital point of your robot, power to your robot. So we'll spend a lot of time making sure that that battery connector is at a fixed point. A lot of teams like to just have that battery connector on your robot, the Anderson battery connector, just laying in the robot and not attached to something, not fixed to a point. We'll affix that to a point, bolt it in, and then we'll even take our Anderson on our battery and bolt that to our robot, so that's never going to come undone. We spend a lot of time on our batteries preparing them for the season. We'll get a set of batteries for our competitions and another set for our championship event, but most teams don't have that luxury. But we'll spend a lot of times prepping the batteries. We clean all the connection points when we get our new set of batteries in. We'll clean them all off. We'll clean all the corrosion off. We'll get new bolts, new star washers in there. We really don't want those connectors moving around and getting loose on the robot. We baby our batteries. If they're not in the robot, they're on the charger at all times. We don't leave a battery off the charger at all. We have a battery per charger. Some teams can't afford that, I understand, but you really got to baby your batteries. Not dropping them, not picking them up by the connectors. I've watched high-end teams carry batteries with the connectors, and yeah. So baby your batteries. We'll test each battery after each competition to make sure that, okay, it's still good for the next competition. We'll load test them and make sure that they're still holding a charge and keeping our curve of our battery. We're getting more and more into watching our discharge curve and everything on our batteries, but if it's on a robot, it's on a charger is what we tell all of our kids.
Not a battery beak.
No, not a battery beak. So we have some data logging that we do on like our practice spots. We'll watch it on the battery. We'll watch the discharge curve, logging it on our robot. So we'll go through with our practice spot basically, and then if it's suspicious with that, I'll take it over to just a regular electronic load tester. There's one, I forget I don't got the name brand on with me, but 254 has it here actually right now. It's the one I use from them. I got it from them a while back, and it's an electronic one. It'll put a constant current on it for a while, and you can watch that curve on there. Yes.
So do you use a driver station?
Yes. Yeah. Yep. And then we also have some other logs that we log to a USB drive for certain things. Like last year, we had we wanted to watch our pressure over the competition, so we had a pressure transducer on our robot, and we logged that to a CSV file on our robot and watched that through a match. So, yeah, and then understand all your robot articulations. Another one is standardized polarity on the 775 Pros. We'll once again connectorize that with some sort of connector. We use Andersons, but you guys can use spade connectors or items like that. We'll always put the black on the one with the notch, the red on the other one, and we'll have spares soldered and done on that. They're finding that they're having some failures with some of the 775 Pros when you're soldering them, but just be careful when you're soldering those not to apply a lot of heat to that connector. So we'll standardize on all the polarity, and we'll actually put a pin in Anderson to keep them from coming undone and to where you can't swap it around. On the robot, nowhere on the robot is there a black to a red or a red to a black where we've swapped it real quick if we needed to. We always keep it red to red, black to black. We don't ever swap it just to get it to go the opposite way of what we think it needs to go. We always keep it same all the way through, so we're not trying to guess and trying to figure out, okay, oh, we got this now we need to fumble and figure it out. We try to keep it all the same throughout the robot. Yeah, just to make it simpler for you when you're in eliminations and your robot breaks. Yeah, zip tie. We zip tie all of our connectors. Sometimes with, if you're using spade connectors, I'll shrink wrap over that connection to keep them from coming undone. So if you're not using Andersons and you use insulated spade connectors, I'll put a piece of shrink wrap completely over that and it'll keep it pretty tight. Yeah, PoE injection for the radio, just one less connector you have to deal with on there. Twisting, twist. On some of the more delicate, this was older stuff, not now. We'll twist the wires to some of our sensors to keep interference if we're running them with a big current path of wires to our motor train or something like that. It's going through area that there's going to be a bunch of wires in parallel to keep the magnetic induction from going on our sensor wires. So we don't really have to do that too much more with the way everything is. That was the CAN bus. Yeah, we'll twist that. Yeah, we definitely twist the CAN bus. We make our own CAN bus twisted wire at the beginning of the season. We'll just buy some and twist it together. We made a little jig to twist it, but yeah. We made like a wire twister, like in a big. We looked on like how to twist wire on the internet, and we kind of copied a big wire machine. We have a little wood box that we hook to a drill, and holds each spool individually, and spins it off as well. We'll just spin off a bunch of lengths in the shop.
Yeah, the trick I use, you just take the two wires and stick them in the truck.
Yeah, it likes to. If you get it too twisted, it likes to like shrink up on itself. So we spent some time at a kid make an actual spool wire twister.
You're all going to go home and do this, right?
Yeah. Pneumatics. We use the small pneumatic tubing for most of our items on our robot. We'll use the 5/32 tubing. It weighs a lot less than what the 1/4" tubing does. And it's just as cheap as the regular pneumatic tubing. And it's the same price on the fittings. So we use that a lot of places. It's a lot easier to put into somewhere small or something like if we have a small little actuation. And for the flow rates to some items, it doesn't really matter. Last year, there was a lot of pneumatic actuator kickers that kick that cube up on top of the thing. That's where you're going to use the 1/4" tubing. But very, very little 1/4" tubing was used on our robot this year, just for the main pressures of our robot, from the air compressor to our tanks, and from the tank to our pneumatic manifold, and then from the pneumatic manifold, we ran 5/32 out to all of our actuations. There's very, very little 1/4" tubing to an actuation on our robot, but sometimes we'll need to run the 1/4" tubing just based on what this actuation is. The less brass, the better. Just for weight wise for your robot, you're always going to be close on weight. Everybody's always close on robot. So robot weight. We'll use the plastic push to connect connectors everywhere. Automation Direct came out with some regulators that are really small and fairly cheap now that are light and they're all push to connect. Before you would have to make a big brass manifold to hold all that stuff down, and now we can just push to connect all those Automation Direct regulators and pressure gauges and items in there. And then use the McMaster car pressure relief valve. I have had robot inspectors call us when they check the blow off on our robot for overpressure. we spend hours trying to get that right in seasons. And I'm happy now that they don't require just that one anymore. So they have the one that's set for McMaster-Carr for 125 PSI. It's really, really precise. So that's probably the most, I would say that's the most precise pneumatic item on your robot is that, that blow-off valve. So we'll use that even to check our gauges. We know that that's popping at 125. And we've had in years past gauges be off 5 PSI in our range that robot inspectors have called us on. So use the McMaster-Carr blow-off valve. I think it's like $5 on there, and that'll save you a lot of time at the competition if it's your first year there. The robot inspectors are really adamant sometimes about that blow-off valve. Sometimes they'll glance right over it, but use the McMaster-Carr one. We've also had, with the automation direct regulators, we've had sometimes the regulator drift on us. So if you're not doing something that's requiring a lot of precise pneumatic pressure on a clamping or a pushing, then it's fine to use that. But if you're going to be needing something that's very precise on your clamping or pushing or whatever, then go back to the original Norgen pressure regulators. They're really precise. Yeah. Spend a lot of time checking for leaks with your pneumatics. A lot. That air compressor is going to run a lot on your robot and take a lot of power away from your battery and available to everything else on your robot. So, and you're I'm losing my train of thought here. At the start of the match, your robot's going to sit there for a good 5 minutes if everything's running right before the match even starts. So if your robot's leaking and you have a pressure dependent thing for your robot to do its task on the game, then you're going to be out of air by the time your match starts. So spend a lot of time checking for leaks. Even when you get just spend a lot of time on it. Spend time on your max manifold, the gaskets on them when you assemble them. If you assemble them incorrectly, they like to leak out the sides and through the vents. So spend time assembling your pneumatics manifold. And then tight bend radiuses on all the push to connect connectors. They like to leak if you come off at a real high bend radius on them. So we'll make sure that we have a good, I'm trying to draw an example of this. I used to have a picture in here, but if it comes off and goes at a 90-degree angle, what it is to the push to connect fitting, it's going to leak. And we'll make sure that it's straight, coming out straight, and then loop down and around. All threaded connections into the cylinders. We'll Teflon tape them. Sometimes with the pre-dipped Teflon taped fittings that you can get, sometimes I'm not a fan of them. I like to Teflon tape my fittings in and of themselves. The Teflon tape, the ones that come pre-dipped with the stuff on there, I'll take off, scrub it off with like a brush or something like that and tape it myself. It tends to gall the threads sometimes when you put it into the fitting, I've found. So I don't like using the dipped Teflon taped threaded connectors. So spend time on that, check for leaks. I'll make up a solution and use a Q-tip of like Windex and a Q-tip and check all the connectors, all the fittings, all that, and just go around. The air will make the Windex bubble real quick, and you can find your leak. And then cut the tubing straight at a 90-degree angle to itself. A lot of people like to just use a pair of flush cutters or wire cutters to cut it, and that doesn't allow sometimes the alligator clips to hold that tube all the way in, and it'll blow off sometimes or leak. So we actually from Automation Direct, there's a tubing cutter that works really well, and I think it's like $1 And we'll use that to cut our pneumatic tubing to make sure it's nice and straight when you're running pneumatic tubing. Yeah. Batteries. Once again, always be charging. Yes.
Computer world, we've been taught that our lithium-ion batteries last better if you discharge and charge rather than keeping charged all the time. You're always plugging yours in.
Yeah, on a lead acid battery, you're pretty much damaging it no matter what you do. Lead acid battery is like the worst thing ever even for what this application is. So if you're doing nothing, if it's just sitting and discharging, you're damaging it. We've found. So we just always charge them. They're the chargers. All the chargers you got have a smart trickle charging feature to them and monitor the battery and make it and keep it up on its voltage. So we just always put them on the trickle chargers and charge them.
All summer when you go.
Yep. They just sit there on the chargers. At the competition, we'll rotate through the batteries. We make sure that we don't use the same battery from the last match. We'll always have a fresh charge battery. We'll spend time making sure we label, number, and track what battery is used in what match, just to make sure that, okay, we had something go wrong in that match, and just to have traceability of what happened. So plan a rotation for your batteries. Don't use them one after another. And then we always use another couple of batteries just for our practice rounds and practice items instead of using the main competition set when you're at the competition. So we'll have the practice batteries for the practice field and for the, just running around in the pit. So we'll have we'll take the battery out from the robot, put it on the charger, and then put our pit battery in that we'll use to test our robot, program the robot. We're using a different battery than from what the main battery is. And then we'll test each battery with the battery beak before we put it in the robot just to make sure it's good. You zip tie and bolt that connection. And then a good battery strap. You want to keep that battery in your robot. I've seen robots, batteries bounce completely out of the robot. And then also go around and move in the robot. So if that battery's not strapped down and held, it's going to make its way out of wherever it is. So secure your battery. Non-Reno Ethernet port and labeling. Same thing. Once again, we're talking about that Ethernet port on the robot. The one in your RoboRio is just as fragile as the one on your radio. So once we've plugged that Ethernet port into our robot, we've hot glued it, potted, and actually we've printed a strain relief off of that port now, off of the bolted hole. There's a couple holes that are standard on every RoboRio that have the brass connectors. And we've 3D printed a strain relief even for that. So that connector's immobilized and is not moving around in that port. The Ethernet port's it's the worst connection ever. And then labeling. Label your battery where your breaker is going to be, your breaker disconnection. We label all of our sensor connections. Sometimes we've gone away from color coding what breakers go to what Talon, just because we haven't ran into issues that we need to troubleshoot. The main power distribution, we try to not have to deal with that at a competition, is the main power distribution to all the devices. We make sure that we are not having to have that as an issue before we get there. So label all your sensor connections where they plug in. We'll label that at both ends. And even at the sensor, we'll label what port it goes into on what Talon or RoboRio. Sources for some of our stuff, we buy a lot from PowerWorks, McMaster-Carr, Automation Direct. Automation Direct's like my most favorite website. I use them weekly for my work. So they have a lot of stuff, and they're getting a lot more items on there. It's kind of a plug for them. But Automation Direct's got wire connectors and pneumatic components, and it's all really cheap. So, and good quality stuff. I'm I'm very happy with their stuff. And then DigiKey. I think the only things we really buy from DigiKey are the cross-load electronic ribbon cable connectors and PWM connectors. But once again, we don't have to do the PWM connectors anymore. So, yeah. Questions? It was kind of a lot of information. Yeah.
Where do you get the, you said that first has the wire cutter like $1 really good for wire cutters.
What was that?
You said that there was a really good wire cutter.
Yeah, we get them from Fry's. And they're the greenly branded Fry's wire stripper. I think they're at Fry's. They're the only greenly ones in their wiring section, wire strippers. So, yeah. Yes.
Can I take a picture of that table you had with like what page is good for?
Yeah, that's in the rule book as well. But yeah, you can. Oh, where did I passed it? Oh no, I didn't. It's way back here. There you go. Yeah.
Do you try to match high current wires like to both sides of the drivetrain?
In years past, we've done that. We try to keep them the same. Sometimes you can't. I know in our drivetrain, we try to keep, we've had in years past problems with putting Andersons in that path for the Talon SRXs. So we've eliminated that point now, but sometimes you can't. Like last year, I know it was not symmetrical. So, and when we can, but you're not going to always get it.
What connectors do you use for your CAN wires out of the Talon SRX?
We solder them. And I really don't like doing it, but we solder them. We'll actually solder in 2 spare Talons into that chain, so we're not having to unsolder them if there's a problem. Because I just have not found a connector I'd like to do that. I've spent a lot of time looking at what I want to do for that, and yeah, I wanted to do those too, and I still didn't find ones that were small enough that I liked.
We're using Anderson now on a 4-foot wire.
Yeah. When we get new Talons in, most of the time we'll just standardize them to the length with Andersons on either end, and we'll cut that wire on for the CAN to a length, and we leave it like that. And we'll spend the time to solder each connector and make sure we're not trimming that. So like last year's practice spot, I just last Thursday unsoldered that whole chain out of there so we can get the Talons off of it for our off-season robots. So we solder them. I wish I had a better source for that. I really don't like doing it, but we solder it. Yeah, I've looked into that too. There used to be a problem when they would crash, that if you lost the connection, there would crash quite a bit of it. And I'm still on that mindset of like, okay, if we lose the CAN chain, it's going to crash the robot. So we solder them. Any other questions? Yeah. Yeah, no, I do. Yeah, I use some of the ferrules. Sometimes with the wire we use, it doesn't fit into the PCM or anything like that. So we'll spend the time to strip it and put it in there and do that. But we don't use that many ferrules actually. Well, cool. Well, thanks for coming.
If my team colors are pink and blue, should I use that for the wire?
You can't actually. There's only a certain set of rules of colors that you're allowed to use. So.
Only we went to that wiring workshop. Yeah. Thanks, Ryan.
Yeah.
It's a rosette.